This week, AI didn't just move fast, it rewrote the rules. A leaked next-gen AI model sparked fears of market chaos. Microsoft quietly introduced an AI system capable of solving billion-dollar problems in minutes. And a humanoid robot crossed a line many believed was years away, solving one of robotics' hardest challenges. At the same time, Sam Altman revealed OpenAI's roadmap for 2026, raising serious questions about where AI is really headed. At Davos, AI leaders openly clashed over one brutal prediction. Are half of today's jobs about to disappear? And behind it all, the global tech race is accelerating, with the United States and China unveiling massive future projects. This isn't speculation anymore. This is happening, right now. In this weekly recap, we're breaking down every major AI development you need to know, what it means for technology, business, and society, and why 2026 may arrive much faster than anyone expects. Let's start with the leak that could shake global markets. They left breadcrumbs in the code, 28 references scattered across 114 files. And now we know what's coming. DeepSeek just accidentally revealed their next weapon. It's called Model 1. And based on what developers found buried in their GitHub repository, this thing is about to rewrite the rules of AI again. Here's why you should care. Exactly 1 year ago, a small Chinese AI lab released a model called DeepSeek R1. Within 24 hours, NVIDIA lost $593 billion in market value, the single biggest stock crash in Wall Street history. Why? Because DeepSeek proved you don't need billions of dollars and endless GPU farms to compete with OpenAI and Google. They built something just as powerful for under $5 million. And now they're back, with something potentially bigger. But here's what nobody noticed. This wasn't supposed to happen. DeepSeek didn't announce Model 1. They didn't write a press release. They simply updated some code on January 20th, 2026. And eagle-eyed developers started digging. What they found changes everything. The leak happened in something called FlashMLA, DeepSeek's attention mechanism for processing AI. Inside the updated code, developers discovered 28 references to an identifier called Model 1, not an update to their existing V3.2 system. A completely separate branch. A new architecture running in parallel. This is where things get interesting. The code shows fundamental changes. Model 1 uses a different memory layout than anything DeepSeek has built before. It handles data differently. It processes information differently. And here's the kicker. It's optimized for NVIDIA's Blackwell architecture. Those are the B200 GPUs that don't even officially exist yet. DeepSeek is building for hardware that isn't commercially available. Think about what that means. But the real breakthrough isn't the chips. It's something they're calling engram. Remember how your brain works? You don't recalculate that Paris is the capital of France every single time someone asks. You just know it. It's stored. It's instant. Current AI models don't work that way. Every time they need a fact, they have to reason through it. They waste computational power recreating knowledge they've seen a million times before. Engram fixes this. It separates memory from reasoning. Here's the genius part. Instead of forcing the AI to use expensive neural networks to remember basic facts, Engram creates a lookup system, like a massive instant access database. When the model needs to recall something simple, it doesn't think, it looks it up instantly, using something called O1 complexity, which in computer science means constant time retrieval regardless of how much data you have. And this changes everything about how AI works. Traditional models mix two completely different jobs into one system: static memory and dynamic reasoning. It's like using a supercomputer to add 2 plus 2, wildly inefficient. Engram splits them apart. Facts go into fast memory lookups. Complex reasoning uses the actual computational power. The results are insane. In testing, models with Engram jumped from 84% accuracy to 97% on long context tasks. That's not a small improvement. That's the difference between basically useless and actually reliable. And here's where it gets scary good for developers. Engram can handle over 1 million tokens of context. That's not a typo. 1 million. That means you could feed it an entire codebase, not snippets, not files, the whole thing, every function, every dependency, every connection. And it would understand all of it. Internal benchmarks claim V4 is beating Claude and GPT-4 on coding tasks, specifically repository-level coding. The kind where you need to understand how changing one file affects 50 others. The kind that currently makes AI assistants hallucinate and crash. But there's more. DeepSeek published another paper in early January about something called MHC, Manifold Constrained Hyperconnections. It sounds academic, but what it actually does is wild. It makes neural networks learn faster by letting information flow across layers more efficiently, like upgrading from dial-up to fiber optic. These aren't separate features, they're working together. Ngram for memory, MHC for reasoning, MOE architecture for efficiency, all running on optimized kernels designed for next-generation hardware. Now here's what makes this truly disruptive. DeepSeek allocated about 20 to 25% of the model's capacity to Ngram memory. The rest goes to computational experts. They found a U-shaped scaling law that shows exactly how to balance static memory against dynamic computation. Too much memory, performance drops. Too little, same problem. They found the sweet spot. And remember, this entire system is being designed to run on consumer hardware, dual RTX 4090s, or a single 5090. You could potentially run a GPT-5 class model on hardware that fits under your desk. The timing is perfect, or perfectly calculated. DeepSeek is targeting a mid-February release, February 17th, Lunar New Year, exactly 1 year after R1 destroyed the stock market. They're not hiding the pattern, they're advertising it, and the market knows what's coming. Last time, they triggered a $1 trillion tech stock sell-off. This time, they've been quietly building something more sophisticated, more targeted, specifically designed to dominate the one area where Western AI companies still claim superiority: coding. If V4 delivers on these internal benchmarks, it's targeting Claude Opus 4.5's 80.9% score on SWE Bench Verified. That's the gold standard for AI coding assistants. Real GitHub issues, real bug fixes, no multiple choice. Either the code works or it doesn't. Claude currently owns that record. DeepSeek is coming for it, and they're doing it with a model that costs a fraction of the price to run. DeepSeek R1 was 20 to 50 times cheaper to use than OpenAI's O1. The geopolitical implications are staggering. Western chip export controls were supposed to slow down Chinese AI development. DeepSeek keeps proving those controls don't work. They trained R1 on restricted H800 chips. Now they're building V4 with memory systems that reduce GPU dependence entirely. Every time the West restricts hardware access, DeepSeek responds with better software, and it's all going open source. Unlike OpenAI and Anthropic, which have moved toward closed systems and billion-dollar valuations, DeepSeek keeps releasing everything. Code, weights, research papers. They're not building a business, they're building an ecosystem, and every release makes their technology harder to ignore. The development community is already preparing. Forums are buzzing with setup guides for Ultima and VLLM instances. Developers are planning their migration strategies. Some are waiting to see the benchmarks. Others are ready to switch the day V4 drops. Here's what nobody's saying out loud. If V4 actually beats Claude and GPT on coding while running locally on consumer hardware, the entire AI API business model collapses. Why pay per token when you can run the same quality model on your own machine? Why send proprietary code to external servers when you have equivalent capability locally? This wasn't an accident. This was a marketing campaign disguised as a code leak. The AI community is treating Model 1 like an Easter egg hunt. Every commit gets analyzed, every file change documented. Developers are reverse engineering the architecture from code comments and variable names. It's like watching people reconstruct a puzzle from shadows. And DeepSeek hasn't said a word. No official confirmation, no press releases, just silence, which makes the hype grow stronger. Here's what we're watching for when V4 launches. First, the actual SWE bench score. Does it beat 80.9% or fall short? Second, long context performance. Can it really handle million token code bases without degrading? Third, local deployment reality. Do those consumer hardware claims hold up under real-world testing? Fourth, and maybe most important, integration. Does it work with Cursor, VS Code, all the tools developers actually use? Or is it powerful but isolated? And Model 1 suggests they're accelerating. February 17th. Mark your calendar. Whether you're a developer, an investor, or just someone who cares about where AI is heading, this release matters. Because if the last year taught us anything, it's that DeepSeek doesn't bluff. When they say they built something, they built it. The code is real. The papers are published. The architecture is documented. All that's left is the launch. And based on everything we've seen, it's going to be explosive. Next, let's look at how Microsoft's new AI is solving billion-dollar problems in minutes. Microsoft just released an AI that can solve problems worth billions of dollars in minutes, and it's called OptiMind. And if you're hearing that name and thinking, okay, cool, another AI model. But no, this one's actually different. It's not trying to be ChatGPT, it's not another chatbot or image generator. This thing is solving a very specific problem that's honestly been blocking real-world business decisions for decades. And if it works the way Microsoft says it does, we're talking about a pretty massive shift in how entire industries operate. Okay, so here's what's happening. Every single day, massive companies are trying to solve these incredibly complex problems. Like, imagine you're FedEx and you need to figure out the best way to route 10,000 trucks across the country while minimizing fuel costs, meeting delivery deadlines, and dealing with traffic and weather. Or you're running a factory and you need to schedule production across 50 machines, 15 products, and 100 workers without creating bottlenecks. These aren't guessing games. Companies use mathematical optimization solvers for this stuff. And these solvers are genuinely brilliant. They can process millions of variables and tell you the mathematically perfect answer. But here's the catch. The solver isn't actually the hard part. The hard part is getting your problem into a format the solver can understand. You can't just tell it, hey, I need to optimize my supply chain. You need to translate your messy real-world problem into precise mathematical language, something called a mixed integer linear program, and this translation process requires serious expertise. We're talking about people who've spent years studying operations research. It can take them days or weeks to convert one business problem into the right mathematical model. And if they mess it up, the solver gives you complete garbage. So you've got this ridiculous situation where companies have access to these incredibly powerful tools. But there's this brutal bottleneck right at the beginning. The hardest part isn't solving the problem. It's translating English into math. And that's been true for decades, until now. OptiMind is Microsoft's solution to this. You describe your optimization problem in normal language. Supply chain planning, workforce scheduling, resource allocation, whatever. The model reads it, figures out the structure, and gives you two things. First, a complete mathematical formulation. Second, actual working Python code that you can run immediately, not pseudocode, not an explanation. Actual executable code using Gurobi, which is one of the industry standard solvers. It defines all the variables, sets up the constraints, specifies what you're trying to optimize, runs the solver, and prints the answer. If this works as advertised, you just turned a multi-day expert-level job into something that takes minutes. Now let me tell you how they built this, because the approach is genuinely clever. OptiMind is a 20 billion parameter model. That's actually pretty small by today's standards. It uses this mixture of experts architecture, which basically means only about 3.6 billion parameters activate for any given problem. So it's got huge capacity, but the compute costs stay reasonable, and the context window is absolutely massive. 128,000 tokens. That's important because real optimization problems get complicated fast. Multiple stages, conditional constraints, weird edge cases. With that much context, the model can hold your entire problem description and think through it properly. And get this, it's released under the MIT license, completely open source. You can use it commercially, modify it, integrate it into your systems, whatever you want. Microsoft Research just dropped a specialized AI model for free and said do whatever you want with it. That's pretty rare. But the really smart part is how they trained it. Microsoft didn't just dump more data into a bigger model. They did something way more strategic. They started by breaking optimization problems into 53 specific categories. Traveling salesman problems, scheduling problems, network design, all these different types. Then they ran the base model on samples from each category and watched where it screwed up. And instead of just retraining, they brought in actual optimization experts, real people who do this for a living. These experts looked at the failures, figured out the patterns, and wrote specific hints for each problem class. Like for the traveling salesman problem, there's this thing called subtour elimination constraints. If you don't include them properly, the solver gives you routes that have disconnected loops, which is obviously useless. The experts wrote hints explaining exactly how to handle that. Then Microsoft used those hints to clean up the entire training dataset. They regenerated solutions using the hints, filtered out inconsistencies with majority voting, and ended up with much cleaner training data. And here's something crazy. They found that between 30 and 50% of public benchmarks in this field are just wrong. Missing information, ambiguous descriptions, incorrect answers. So they're not just building a better model. They're basically saying the entire way we've been evaluating these systems is flawed. When you actually use OptiMind, it's not just a one-shot thing. It's a multi-stage system. First, it figures out what type of problem you're asking about. Then it pulls up the relevant expert hints for that category. Then it works through the reasoning, builds the mathematical model, and generates the code. And if you want even better accuracy, it can generate multiple solutions, run them all, and pick the one that shows up most consistently. It's applying the same kind of verification logic that solvers use to check its own work. There's also this multi-turn correction mode, where it actually runs the code, sees if anything breaks, and fixes it. So if the solver throws an error, or the constraints don't work, the system revises the formulation and tries again. It's almost like having an expert who can debug their own work. The performance numbers are solid. Microsoft says OptiMind improves accuracy by about 10% over the base model, and beats every other open source model under 32 billion parameters. On their cleaned benchmarks, it's competitive with way larger proprietary models. And remember, this is something you can run locally. You're not sending your sensitive business data to someone else's servers. Now, Microsoft is upfront about the limitations, which I actually respect. The model can still generate wrong formulations or code that doesn't work. It's specialized for operations research problems, so if you ask it random stuff, no guarantees. They recommend keeping a human in the loop for anything important, and explicitly warn against using this for critical applications. Healthcare decisions, financial approvals, legal judgments, anything where you can't afford to just trust an automatic result. And they strongly suggest sandboxing any generated code before running it, which makes sense because this thing outputs code that actually executes and interacts with a solver. If you want to try it, it's on Hugging Face and Microsoft Azure AI Foundry. You can serve it using SGLang as an OpenAI compatible endpoint, so it fits into existing workflows pretty easily. You need a Gurobi license because the generated code uses Gurobi Pi. So what does this actually mean for the real world? If OptiMind keeps improving, optimization stops being this expert-only thing and becomes accessible to way more people. Supply chain teams, logistics planners, operations managers, anyone who understands the business problem can describe what they need and get working models back. That's a genuinely big shift. We're not just talking about AI that writes text or makes images. This is AI that generates mathematically rigorous decisions that industries can actually use, and that could change a lot about how businesses operate. Now let's move to robotics, where Figure's Helix Aero 2 just solved a problem many thought was impossible. A robot just did something that changes everything we thought we knew about machines. It loaded a dishwasher, from start to finish, 61 different actions, 4 minutes straight, no human touching a controller, no one guiding it, no safety net. And that might sound boring until you realize what it actually means, because this isn't about dishes. This is about the moment robots stopped being tools and started becoming something else entirely. Figure AI just released Helix O2, and the robotics world is losing its mind. But here's what nobody is talking about. This thing replaced over 100,000 lines of code with a single brain. One neural network now controls the entire body. The legs, the arms, the fingers, the balance, everything. Think about that for a second. Every robot you've ever seen moves like a robot. Stiff, mechanical, calculated. That's because engineers had to program every single movement by hand. Turn left, lift arm, grip object. It's like puppet strings. Helix O2 doesn't work that way. They trained this system on over 1,000 hours of human movement data. Real humans doing real tasks. And the robot learned to move like us, not just imitate. Actually move like a human moves. And this is where things get interesting. When this robot's hands are full, it uses its hip to close a drawer. When it needs to close a dishwasher door, it lifts it with its foot. No one programmed that. The robot figured it out on its own. This is called loco manipulation. And until now, it was considered one of the hardest unsolved problems in robotics. See, walking and using your hands at the same time seems simple to us. We don't think about it. But for a machine, coordinating legs and arms and fingers while maintaining balance while completing a task was basically impossible. Previous robots had separate systems for walking and separate systems for grabbing things. And connecting them was a nightmare. Brittle, buggy, prone to failure. Helix O2 threw all of that away. One brain, one system, everything connected. And the precision is honestly hard to believe. The fingertip sensors can feel forces as small as 3 grams. That's lighter than a paperclip. The robot can pull individual pills out of a medicine box without crushing them. It can dispense exactly 5 milliliters from a syringe. But here's the part that should make you pay attention. This entire system runs on chips inside the robot. No internet connection. No cloud servers processing commands. Everything happens locally, instantly, at 1,000 operations per second. That means this robot works anywhere. Factories without Wi-Fi, homes without internet, remote locations with zero connectivity. And that changes the entire game for where these machines can actually be deployed. Now let me tell you why this matters way more than you might think. Figure AI isn't some tiny startup working out of a garage. They just raised over $1.9 billion. Their valuation hit $39 billion in September. That's a 1,400% increase in 18 months. Jeff Bezos invested. Microsoft invested. Nvidia, Intel, Amazon, Qualcomm. The biggest names in tech are betting enormous money on this company, and they're already deploying robots in the real world. BMW was their first commercial customer. Those robots are working in a factory in South Carolina right now. And according to Figure, they're operating 400% faster than earlier versions with 7 times the success rate. Bloomberg reported that UPS is in partnership discussions for package handling. And here's something most people missed. Figure partnered with Brookfield Asset Management. That's one of the world's largest real estate companies. They manage over 100,000 residential and commercial spaces. The goal is to collect real-world data from actual homes and buildings. They're not just building robots anymore. They're building a training empire. But this is where the story takes a turn. Figure used to work with OpenAI, the biggest AI company in the world. They ended that partnership in February 2025. The CEO, Brett Adcock, said something that explains exactly where this is headed. He said solving embodied AI requires vertical integration, meaning they need to own everything. The hardware, the software, the intelligence. All of it developed in-house. They don't want to rely on anyone else. They want full control. And now they have it. Helix O2 is built entirely by Figure, and it runs on their newest robot, the Figure O3, which launched in October with better cameras, wider field of view, palm-mounted cameras, and soft safety materials designed specifically for homes. Not factories. Homes. Let that sink in for a moment. They're building robots meant to live with you. Now here's what the critics are saying. TechCrunch pointed out that we've only seen carefully edited demonstration videos, short clips designed to look impressive. And the CEO has actually refused to do live public demonstrations. He called them a giant waste of time. That raises questions. Are these robots really as capable as the videos suggest? Or is there still a gap between polished marketing and real-world reliability? Honestly, we won't know until they're deployed at scale, and that's the gamble everyone is watching right now. But let me tell you what the experts who've seen these demos are saying. New Atlas called it jaw-dropping. They said it's the closest thing to the movie I, Robot that anyone has ever built. A robotics analyst named Scott Walter said something that stopped me cold. He said the Figure O2 robot is already more efficient than the average worker. And this is the worst it will ever be. Read that again. This is the worst these robots will ever perform. Every single day, they're getting better. Every update, every training run, every new data point, improvement after improvement compounding over time. Now here's where I think this is really going. Figure AI is building a factory called BotQ. First year target is 12,000 robots. But by 2029, they're planning to produce up to 200,000 units per year. And the CEO has said the goal is to sell these robots for under $20,000 each. Think about what that means. A machine that can walk, balance, manipulate objects with human-level precision, learn new tasks on its own, and work without internet connectivity for less than a used car. We're not talking about some distant science fiction future. Figure is shipping robots right now, to real customers, doing real work. And Helix O2 is just the beginning. The original Helix only controlled the upper body. Helix O2 controls everything. What do you think Helix O3 will do? Helix O4? The improvements aren't slowing down, they're accelerating. So here's the question you should be asking yourself. What happens when robots that can do almost any physical task cost less than hiring a human for a year? What happens to jobs, to industries, to the economy? Some people are terrified, some people are excited, but almost nobody is prepared. And this moment right now, before any of this becomes mainstream news, before everyone is talking about it, this is the window where you get to understand what's coming before most people even realize it's happening. The robot revolution isn't starting someday. It just started. Next, let's break down Sam Altman's reveal and what OpenAI's 2026 plan really means. Sam Altman just admitted something that should make every software engineer nervous. He said OpenAI is slowing down hiring, not because business is bad, because AI is getting so good. They simply don't need as many humans anymore. And that's just the beginning of what came out of this private developer event. Here's why this matters to you. Whether you're a programmer, a student, or someone just trying to figure out what the future looks like, the next 18 months are about to reshape everything. The way we work, the way we learn, even the way we think about what skills actually matter. And buried in this conversation were warnings that most people completely missed. Let's start with the bombshell about software engineering. When asked if AI would reduce demand for programmers, Altman didn't sugarcoat it. He said the job is going to super change. Those were his exact words. Not evolve, not adapt, super change. But here's what nobody noticed. He said by the end of this year, for just $100 to $1,000 in AI costs, you'll be able to create software that would have taken entire teams an entire year to build. That's not a decade from now. Think about that for a second. $1,000. One person. Software that used to require a team working for 12 months. And this changes everything about how companies think about hiring. Altman revealed that OpenAI is dramatically slowing how quickly they grow their workforce. He said they expect to do so much more with fewer people. And he warned other companies to do the same. His exact advice was, don't hire aggressively, then suddenly realize AI can do most of the work and have some very uncomfortable conversation with your employees. That uncomfortable conversation is coming for a lot of companies this year. But here's where things get interesting. Altman also admitted something about his own behavior that reveals how seductive these tools really are. When he first started using Codex, OpenAI's coding agent, he told himself he would never give it complete unsupervised access to his computer. He was absolutely confident about this. He lasted 2 hours. That's it. 2 hours before he turned on full access and never turned it off. And he's not alone. He said everyone at OpenAI has done the same thing. The convenience is just too powerful to resist. Now, why does this matter? Because Altman then explained his biggest fear. He said people are going to get comfortable trusting AI at a certain capability level. Then the models will get dramatically more powerful and harder to understand. Because we already trust them, we'll sleepwalk into giving them even more access without building proper security systems. His exact words were, "We will sleepwalk into something." And it gets darker. When asked about biosecurity, Altman said something that should make headlines. He said if something goes really wrong with AI this year, visibly really wrong, bio would be a reasonable bet for what that could be. He's talking about bioterrorism. He said AI models are already quite good at biology. And the current strategy of trying to block dangerous outputs isn't going to work much longer. His solution? The world needs to shift from blocking to resilience. He compared it to fire. Centuries ago, cities kept burning down. We tried to restrict fire. It didn't work. Eventually, we developed fire codes, flame-resistant materials, and better infrastructure. He said we need to do the same thing with AI, because the models are coming whether we're ready or not. Now let me tell you about the future Altman sees for software itself. He said he no longer thinks of software as something static. If he has a small problem, he expects his computer to write custom code immediately to solve it. No downloading apps, no searching for tools, just instant personalized software. He predicted that operating systems will fundamentally change. We'll all have software that's constantly evolving and customizing itself just for us. The way you use your computer will be different from the way I use mine. And our tools will adapt to match. And here's the mid-video hook you need to hear. Altman revealed something about GPT-5 that explains a lot of complaints you might have seen online. He admitted they screwed up. Those were his words. He said GPT-5's writing quality dropped compared to GPT 4.5 because they focused too much on reasoning and coding. They had limited bandwidth and they chose to prioritize intelligence over writing quality. But he promised future versions will fix this. He said intelligence is surprisingly fungible, meaning if they can make a model smarter at one thing, they can make it smarter at everything. And speaking of smarter, here's the timeline he gave for cost reductions. By the end of 2027, he expects GPT 5.2 level intelligence to cost at least 100 times less than it does today, 100 times cheaper in about 2 years. But there's another dimension OpenAI hasn't focused on until now. Speed. He said more developers are pushing for faster outputs, not just cheaper ones. Some people want the exact same result, but in 1/100th of the time, even if it costs more. And OpenAI has to figure out how to balance these two very different demands. Now let's talk about what this means for education and skills. A student asked Altman what skills matter most in the age of AI. His answer was surprising. He didn't say learn to code. He didn't mention any technical skill. Instead, he listed soft skills, high agency, generating good ideas, resilience, adaptability. He said these matter more than any specific hard skill right now. And here's the encouraging part. He said these are all learnable. He's seen people transform in 3-month bootcamp-style programs. People can become formidable on all these axes faster than you'd expect. But on education itself, he had a more cautious view. He said he'd keep computers out of kindergarten entirely. He thinks young children should be running around outside, playing with physical things, learning to interact with each other. He mentioned that technology's impact on young children might be even worse than social media's impact on teenagers. And we're still not talking about it enough. For older students, though, he compared AI to Google. When Google came out, teachers tried to ban it. They thought if kids could look anything up, why would they learn? Altman thought that was insane then, and he thinks banning AI tools is insane now. The teaching methods need to change, not the tools. And here's how this all ends. Altman painted two possible futures for companies. In one, humans work alongside AI coworkers, becoming dramatically more productive. In the other, the companies that win are entirely AI. Just racks of GPUs. No people at all. He said he really hopes it's the first one. But he warned that if companies don't adopt AI aggressively right now, they will eventually be outcompeted by fully AI companies that don't have silly internal policies slowing them down. But there's one more thing Altman revealed that shows just how far this is going. He said he's now ready for ChatGPT to look at his entire computer, his whole internet history, everything. He wants AI to have a perfect representation of his digital life, and he believes most users will eventually want the same thing. The convenience is just too powerful to resist. He even talked about building what he called a Paul Graham bot, an AI that could be the ultimate brainstorming partner, something that looks at all your past work, all your code, all your projects, and continuously suggests new ideas. Even if 95 out of 100 suggestions are bad, those 5 good ones could change everything. And here's the part that stuck with me. He compared the current moment to a brief period in chess history. After Deep Blue beat Kasparov, there was a window where human plus AI was better than AI alone. The human would pick the best move from 10 options the machine generated. That's the choice facing every business this year. Adapt fast or get replaced by something that doesn't need humans at all. And that future? It's not decades away. According to Sam Altman, it's already beginning. The question is whether you'll be ready when it arrives.
After that, we head to Davos 2026, where AI leaders clashed over the future of jobs. The CEO of Anthropic just said your job might be gone in 6 months. And the CEO of Google DeepMind disagrees. These two men control the most powerful AI systems on the planet. And last week, they sat on a stage in Davos and told the world completely different things about when machines will match human intelligence. But here's what nobody is talking about. While they were debating, one of them quietly announced a deal that could change everything. Google DeepMind just partnered with Boston Dynamics to put their AI inside humanoid robots. Robots that are shipping this year. This isn't science fiction anymore. This is happening right now. And by the end of this video, you'll understand exactly why the smartest people in AI can't agree on what's coming, and why that disagreement might be the most important story of 2026. Let's start with the debate that broke the internet. January 20th, 2026. The World Economic Forum in Davos, Switzerland. Dario Amodei, CEO of Anthropic, the company behind Claude AI, sits down next to Demis Hassabis, CEO of Google DeepMind. The panel is called The Day After AGI, and what happened next shocked everyone watching. Amodei went first. He said AI will reach Nobel Prize-level intelligence across multiple scientific fields by 2026 or 2027. Not decades from now. Months. He said it's very hard for him to see how it could take longer than that. Then Hassabis responded. He gave AGI a 50% chance of arriving by the end of the decade, 5 to 10 years. Maybe we need 1 or 2 more breakthroughs, he said. Now here's where it gets interesting. Amodei actually admitted he wishes Hassabis was right. He said he prefers that slower timeline. He wishes they had 5 to 10 years. But then he explained why slowing down is impossible. We have geopolitical adversaries building the same technologies at the same pace. Think about that for a second. The man building one of the most advanced AI systems in the world is telling you he wishes he could slow down. But he can't. Because if he does, someone else wins the race. And this is where things get personal. Amodei dropped a bombshell about jobs. He said he has engineers at Anthropic who don't write any code anymore. They just let the AI write it and then edit what comes out. His prediction? We might be 6 to 12 months away from AI doing most of what software engineers do. But he didn't stop there. He said 50% of entry-level white-collar jobs could disappear within 1 to 5 years. And here's the part that sent chills down everyone's spine. He admitted that even Anthropic is planning for layoffs. He said he can look forward to a time when they need less people, not more. Hassabis agreed the pace is terrifying. He told students to stop chasing traditional internships. Instead, become unbelievably proficient with AI tools. That's better than any internship because you're leapfrogging yourself for the next 5 years. Both of them said the same thing at the end. After AGI arrives, we are in uncharted territory. But wait, not everyone agrees with this timeline. Enter Yann LeCun, the godfather of deep learning, the man who won the Turing Award. He used to run AI at Meta, and he thinks both Amodei and Hassabis are completely wrong. LeCun didn't hold back. He called the AI industry completely LLM-pilled. He said everyone in Silicon Valley is digging the same trench. His exact words? We're never going to get to human-level intelligence by training on text alone. Then he went even further. He said there is no such thing as general intelligence. The concept makes absolutely no sense. And those people predicting AGI in a year or two? Complete delusion. This sparked a public fight. Hassabis fired back on social media saying LeCun was just plain incorrect. Elon Musk jumped in with 2 words. Demis is right. But here's the thing. LeCun has a point that nobody can ignore. He explained it like this. An AI might be trained on 30 trillion words. That would take a human 500,000 years to read. Yet a 4-year-old child who has processed way less text, but tons of visual experience understands gravity. Understands that objects still exist when you can't see them. Things that AI still can't grasp. LeCun's argument is simple. AI is disconnected from the real world. It reads about reality but never touches it. And until that changes, we're not getting anywhere close to human intelligence. And this is where the second story comes in. The one that connects everything. 2 weeks before the Davos debate, something huge happened at CES. Boston Dynamics and Google DeepMind announced they're joining forces. DeepMind's Gemini AI is going inside the Atlas humanoid robot. The same Demis Hassabis who was debating AGI timelines is now putting his AI into a physical body. Robert Plater, the CEO of Boston Dynamics, explained why. He said we have the best body, but we need a stronger brain. and nobody in the world is better suited than DeepMind. Think about what this means. LeCun says AI can't reach human intelligence because it's disconnected from reality. DeepMind's answer? Fine. We'll give it a body. We'll let it learn from the real world. The new Atlas robot is unlike anything we've seen before. 6.2 feet tall, 56 degrees of freedom, which is double what Tesla's Optimus has. It can lift 110 pounds. It has 360-degree rotating joints that exceed human range of motion. And it runs on NVIDIA's most powerful robotics chip. But the AI is what matters here. Gemini Robotics works in two parts. The first part is like a high-level brain. It takes goals and breaks them into step-by-step plans. The second part is a vision language action model. It sees the world, understands instructions, and controls the robot's movements. Here's the breakthrough. Instead of pre-programmed routines, this robot actually thinks before it acts. It generates internal reasoning in natural language before moving. It can learn a skill on one robot and transfer that knowledge to a completely different robot. And it runs locally without needing the cloud. This directly answers LeCun's criticism. AI that learns from physical manipulation, not just text. Now here's where it gets really interesting. All of the Atlas robots being made in 2026 are already sold, every single one. They're going to 2 customers only: Hyundai's factories and Google DeepMind's research labs. The timeline accelerates fast. By 2028, Hyundai wants to produce 30,000 of these robots per year. They're investing $26 billion in this. They plan to deploy tens of thousands of humanoid robots across their factories. And every hour these robots operate, they generate data. That data trains Gemini to be smarter. Smarter Gemini makes smarter robots. It's a self-reinforcing loop that will be nearly impossible for competitors to catch up to. Tesla's Optimus is targeting a price around $20,000 to $30,000. Atlas costs around $150,000. But Boston Dynamics isn't going after consumers. They're going after the hardest industrial problems first. As Plater put it, some companies want to put humanoids in homes first. We think that's the wrong strategy. So what does all of this mean for you? Here's the picture that's forming. The brightest minds in AI are racing towards something they don't fully understand. Amodei thinks we're months away from AI that can do most knowledge work. Hassabis thinks we have 5 to 10 years but admits that's not a lot of time. LeCun thinks they're both wrong, but even he says we might see progress in 3 to 5 years. Meanwhile, DeepMind is hedging its bets. They're building the AI that might reach human-level intelligence. And they're building the robots that will put that intelligence into the physical world. Both Amodei and Hassabis said something haunting at Davos. They both wish they could slow down. Amodei called it a crisis. Hassabis said 5 to 10 years is not a lot of time to prepare. But neither of them is slowing down. Because they can't. The race is on. And the finish line keeps moving closer. The robots are shipping this year. The AI is improving every month. The jobs Amodei warned about are already changing. Whether AGI arrives in 18 months or 18 years, one thing is certain. The people building it are moving faster than ever. And they don't agree on where this ends. And finally, let's zoom out to the global race, as America and China unveil their biggest future projects for 2026. So, right now, 2 superpowers are building the most powerful AI systems humanity has ever seen. And the decisions being made in the next 12 months will determine who controls the future of technology for the next decade. This isn't about politics. This isn't about picking sides. This is about understanding what's actually happening. Because most of what you've heard is either exaggerated hype or completely wrong. So let's break down the 10 biggest AI and tech projects coming from America and China in 2026, and I'll show you exactly where each side actually stands. Let's start with AI models, because this is where things get really interesting. OpenAI just released GPT 5.2 in December, and it's genuinely impressive. It beats most benchmarks in coding, math, and reasoning. But here's what most people missed. OpenAI is already working on something called Project Garlic. This is expected to launch as GPT-6 in early 2026. But the approach is completely different from what they've done before. Instead of making models bigger and bigger, they're trying to make a smaller model that retains the knowledge of a much larger system. Think of it like compressing a massive library into something that fits in your pocket, but still has all the information. Now here's where China enters the picture. DeepSeek, the company that shocked everyone last year with their R1 model, is preparing to release V4 around mid-February. And according to internal testing, it might outperform both Claude and ChatGPT specifically in coding tasks. But here's the part that actually matters for regular people. DeepSeek V4 will likely be open source. That means anyone can download it and run it on their own computer. We're talking about GPT-level performance running on consumer hardware. Now, does this mean China is winning the AI race? Not exactly. The reality is more nuanced. America's models, especially from OpenAI and Anthropic, still lead in overall capability and safety research. But China is winning on accessibility and cost. A developer in Germany or Poland can use DeepSeek for free, while ChatGPT Pro costs $200 a month. Both approaches have value. Both are pushing the technology forward. And honestly, this competition is making AI better for everyone. But here's where the real battle is happening. Let's talk about humanoid robots, because this might be the most surprising category of all. Tesla's Optimus Gen 3 just entered mass production. It has 22 degrees of freedom in its hands, can perform over 3,000 different tasks, and Tesla is targeting a price under $20,000. Elon Musk claims Optimus represents 80% of Tesla's long-term value. But when you look at the numbers, something unexpected emerges. Chinese companies aren't just competing. They're already selling robots to consumers. Unitree's R1 humanoid costs $5,900. That's not a typo. Under $6,000 for a functional humanoid robot. UB Tech is planning to produce 5,000 robots in 2026 and 10,000 in 2027. They've already partnered with BYD, Geely, and Foxconn. And here's a stat that surprised me. Between 2020 and 2025, China filed nearly 4 times as many humanoid robotics patents as the United States. That's not a small gap. Now, does this mean Chinese robots are better? No. Tesla's Optimus is almost certainly more advanced technically. But China is moving faster on commercialization and scaling. They're getting real products into real factories, while American companies are still perfecting prototypes. This brings us to the category where America has an undeniable lead. NVIDIA isn't just winning, they're dominating. Their Blackwell chips are so far ahead that according to one analysis, by 2027, the best American AI chips could be 17 times more powerful than Huawei's top offerings. Huawei is trying to catch up with their Ascend chip line. They're planning to double production in 2026 to about 600,000 chips. But here's the problem. Their yield rates are reportedly between 5 and 20%, while NVIDIA achieves 60 to 80%. That means most of the chips Huawei tries to make don't even work. The manufacturing gap is real, and it's widening. But, and this is important, China isn't giving up. ByteDance, the company that owns TikTok, just placed a $5.7 billion order for Huawei chips for 2026. They're choosing domestic over NVIDIA, and Huawei just announced their roadmap through 2028, with the Ascend 950, 960, and 970 chips planned. Will they catch up? Most analysts say no, not in the next few years. But they're building an independent ecosystem, and that has long-term implications. Now let me show you something that doesn't get enough attention. The open-source AI war. Alibaba's Qwen model family just hit 700 million downloads on Hugging Face, making it the most widely used open-source AI system in the world. 6 of the top 10 AI models built by Japanese companies are based on Chinese open-source foundations. Meanwhile, American companies have been more protective of their technology. OpenAI, Anthropic, and Google keep their best models closed source. This creates an interesting dynamic. If you're a startup in Brazil or a developer in Indonesia, Chinese open-source models are often your best option. They're free, they're powerful, and they're accessible. America leads in capability. China leads in accessibility. Both matter. Let's talk about infrastructure spending, because the numbers here are staggering. American cloud providers are projected to spend $600 billion on AI infrastructure in 2026. That's double what they spent in 2024. This is being called the largest technology project in human history. bigger than the Apollo program and the interstate highway system combined. China can't match this dollar for dollar, but they have a different strategy. Their AI Plus initiative is integrating artificial intelligence across manufacturing, agriculture, and services. They're not just building AI, they're embedding it into their entire economy. One former Chinese central bank official predicted this approach will produce over 100 DeepSeek-level breakthroughs in the next 18 months. That might be optimistic, but it shows the ambition. So who's actually winning? Here's my honest assessment. America leads in raw capability, capital investment, and chip manufacturing. If you want the most powerful AI model available today, it's probably American. China leads in deployment speed, cost efficiency, and open source accessibility. If you want affordable AI that you can run yourself, Chinese options are often better. Neither side has a decisive advantage. And that's actually good news for everyone else. This competition is driving down costs. It's accelerating innovation. It's making AI tools available to people who couldn't afford them before. The real question isn't who wins. It's how this competition shapes the technology we all use. In 2026, we're going to see GPT-6, DeepSeek V4, 100,000 Tesla robots, new NVIDIA chips, and probably a dozen breakthroughs nobody expects. Both superpowers are pushing as hard as they can. And here's what I think most people are missing. The companies and countries that figure out how to actually use these tools effectively will matter more than who builds them. A small team using AI intelligently can now compete with massive corporations. A country that integrates AI into its economy smartly could leapfrog others regardless of who developed the underlying technology. The real winners of this race might not be America or China. They might be the engineers, creators, and businesses around the world who learn to work with these tools first. That's the opportunity sitting in front of all of us right now. The question is whether we take it. Share your thoughts in the comments, and if this was useful, like the video and subscribe. Thanks for watching, and I'll catch you in the next one.